In today's lecture, we will estimate ARIMA model by using Box-Jenkins technique. So the first step of Box-Jenkins technique is to estimate or check the stationarity of your data. So for that, uh, I will double click my data, and here it show a graph that is trendy. It means we have to make it stationary. So to make it stationary, we have to write a command, generate GENR, and we have to generate a new variable that is uh, we can say dcpi and is equal to, and we have to take a difference. So you have to write this command. What it command means? It means generate a dcpi variable that is equal to difference of cpi. D stands for difference. D stands for difference here, so it is right as a command here. So just click it and press enter, and here we can see that we have a new variable that is dcpi. So double click it and just go to view and graph and line graph, and here we can check that it is now a stationary graph. What it means? It means that its variable, its variance mean and covariance over the period of time is relatively constant. It should be constant for stationarity. That's are the condition of ARIMA model. So our data is now stationary. As we can see, now we have to estimate our ACF and PACF. What that means? It means just go to uh, parallelogram specification and don't change anything and just click OK. Now we can see that we have ACF and PACF. We can shortly say them as AC and PACF. Here they are written as AC and PAC. Now based on uh, the bars that are out of range, we can estimate our PQ of our data on which we estimate our ARIMA equation. So the first step was to check the stationarity. Second step was to if it is not stationary, convert it into stationary data. The third step was to estimate ACF and PACF for ARIMA P and Q. For P means autoregression, we have PACF, and for our autoregression we have and for our moving averages we have ACF autocorrelation factor. So autocorrelation factor and partial correlation factor, based on these we will estimate our equation. So here we can see that the third bar is over the line, the 4/5 and 6th and 10th line is over the line. Here the third and fourth are over the line. So based on this data we will estimate our equations, and here we will estimate our equation. As we have seen in the graph that partial correlation bar number 3 is out of range. uh, I represent a number of difference taken for making it stationary. Our data was trendy, so we have to take a first difference to make it stationary. So one represent this factor. Q represent autocorrelation. It represent the moving average in ARIMA model, and it is extracted through autocorrelation. Bar number 4, 7 and 10 are out of range. So when we put it in the models, we get three models that are 3, 1, 4, 3, 1 and 7, 3, 1 and 10. So we have here three models. Now we will estimate them on Eviews. Now we will estimate these three models. So just go to estimate equation and write your equation. So DCPI is our variable, C stand for constant, and what we have seen in the model that we have to use P as 3. So here we will write AR1, AR1, AR2, AR3, and for Q we will write 4 in the first model and 7 moving averages in the second model. So it's MA3 and MA4. So this was our first model that represent P is equal to 3, I is equal to 1, as we make it stationary, made our data stationary. So the third was moving average till 4. So the first model was estimated as here. We will freeze it and we will name it as ARIMA model 1. So here we go. Okay, we will change it term as AR1. Okay, so it's save as AR1 because we have to use it in the future for our decision. Then we will estimate our second equation. Here MA will increase to 7 Okay, we will freeze it and name it as AR2 and it will be saved. Okay, now we will estimate our third model and it goes till 8 and 9 and 8 10. Due to my software limitation, I could not able to estimate the third model. But after estimating the third model, what you guys should do is you can select your model based on the following criteria. Uh, the first criteria is the number of significant value. Higher the better. The model with higher value is the better model. AIC and SBC value should be on the lower side. The model with lowest value is the model to go with. And the last is adjusted R square value. The higher the value, the better the model is. Higher R square value shows that the model, uh, uh, you can say it that it can explain your estimation in a better way than the other models. So the answer of different criteria may be vary, but you can select based on these criteria the model that uh, pass maximum of these criteria will be the winner, and it is the model uh, to go with for your estimation. And this is the ARIMA model calculation. It's tricky and somehow complicated, but I will make a video on it that explain step by step explanation, so you can learn and develop your skills based on that videos. Thank you.